easy go.
In previous classes, we have discussed about the wavelength or de Broglie wavelength of an electron, that is 12.27 by root V angstrom. That V is potential difference. Now we have to discuss about the experimental demonstration of wave nature of an electron. That was given by Davison and Germer in 1927. Davison and Germer in 1927. That is the experimental demonstration. There is a filament between cathode and anode के पास एक filament है. There is a filament, and that filament electrons are accelerated from hot filament F. There is a potential difference V between cathode and anode. Electrons are emitted from hot filament F and incident on nickel crystal. That is nickel crystal. Here, the incident electrons are scattered in different directions. The intensity of that electron is obtained by the scattering angle phi. That scattering angle is the angle between incident electrons and scattered electrons. They found that when V means potential difference is 54 volt and phi is 50 degree, there is a collector or detector. Collector or detector is moving on circular scale with large deflection. Circular scale with large angle. When electrons are emitted from filament and they are scattered from nickel crystal, they are scattered in different directions. The angle phi is the scattering angle which forms the intensity of electron. When V is 54 volt and phi is 50 degree, then they found that the intensity of electron is maximum. Here, that is the phi, that is incident rays, and that is the scattered beam. Incident beam and scattered beam. That is phi, and that angle is theta. From this you write theta plus phi plus theta is 180 degree, 2 theta plus phi बराबर 180 degree, 2 theta plus phi is equal to 50 degree बराबर 180 degree, and 2 theta बराबर 180 minus 50 and theta is equal to 180 minus 50 by 2, that is 130 by 2, 65 degree. That is 65 degree. That is 65 degree, 65 degree, and that is 50 degree. मैंने ये कहा कि जब 54 वोल्ट है और फाई क्या है 50 डिग्री है, तब उस स्थिति में इंटेंसिटी ऑफ इंसिडेंट इलेक्ट्रॉन बीम इज मैक्सिमम। और यहाँ पे हम लोग क्या करते हैं, आप इसके बाद एक लॉ है that is lambda is equal to 2d sine theta. Here d is a spacing between adjacent plates, and this value is 0.91 angstrom. Putting this and this in that equation, in equation 1, that is lambda is equal to 2 into 0.91 into sine 65 degree. This value is 1.65 angstrom. That is equation 2. Now, you know lambda बराबर 12.27 by root v angstrom. इससे हम लोग लिख सकते हैं 12.27 by root v means यहाँ v 54, its value is 1.67 angstrom. That is equation 2. Equation 1 that is theoretical value. Equation 2 that is practical value, experimental value. Both the values are same. Equation 2 और 3 nearly same है. इससे ये क्या किया, इससे हम लोग इसको एक्सेप्ट कर लिया गया. इसका मतलब हुआ the theoretical and experimental values are nearly same. So we confirm the experimental demonstration of wave nature of an electron or electrons. Repeat again. You know in previous class, you know lambda बराबर 12.27 by root v angstrom. That is the wavelength of an electron. Here we see that the experimental demonstration of wave nature of an electron that was given by Davidson and Jarmer in 1927. From this experiment, and then the filament, cathode, anode, nickel crystal, electrons are accelerated from hot filament, and the potential difference between cathode and anode is V. Electrons from hot filament incident on nickel crystal. Here, the electrons are scattered in different directions. There is a collector or detector which is moving on circular scale with large angle. That is here the electrons coming from hot filament and scattered. That is the scattering angle. Scattering angle is the angle between incident electron and scattered electron. If V is 54 volt and phi is 50 degree, then a scattering beam, then electrons having maximum intensity from this theta plus phi plus theta. Theta plus phi plus theta is 180 degree. The theta is equal to 65 degree. You know the equation lambda over 2d sine theta. That is Bragg's law. Bragg's law. According to Bragg's law, lambda बराबर 2d sine theta. D is the spacing distance between adjacent plates. Its value 0.91 angstrom. Theta is 65 degree. Putting this value, you get lambda is equal to 1.65 angstrom. Now, you know lambda बराबर 12.27 by root v angstrom. Hence, here V is 54 volt, and solving this, we get 1.67 angstrom. These values are nearly same. That is the theoretical value and that is the experimental value. This confirms the experimental demonstration of wave nature of electron. आप इसे अपने कॉपी में उतार लीजिए, अपने कॉपी में पहले फिगर बना लीजिए, वो फिगर बनाने के बाद कैसे कैसे एंगल निकालिए, ये एंगल निकालिए, दोनों को यहाँ फुट कर निकालिए, इसको सब आप सभी इसे निकाल लीजिए। The next topic is Einstein's photoelectric effect. Means photoelectric effect. ये आइंस्टाइन का फोटोइलेक्ट्रिक इफेक्ट है, लेकिन सबसे पहले हम लोग को जान लेना होगा that was given by first of all by Hertz, then Leonard and at last Einstein. While performing an experiment for the production of an electromagnetic waves in a spark tube, Hertz observed that a spark occurs more rapidly in the air gap of his transmitter when ultraviolet radiations was directed one of the metal plates. उन्होंने इतना ही करके छोड़ दिया। उन्होंने देखा कि इस समय अल्ट्रावायलेट रेडिएशन से स्पार्किंग अकर्स। बाद में Leonard observation, Leonard found that when ultraviolet radiation was made on the transmitter plate of an effective tube enclosing two metal plates, the current flowed in the circuit. But when ultraviolet radiation was stopped, then current does not flow, current also stops. That was given by Leonard. दोनों ने अपना अपना वर्क करके इतना छोड़ दिया। उसके बाद आइंस्टीन ने इस पर एक्सपेरिमेंटल स्टडी किया और इससे रिजल्ट निकाला, जिसको आइंस्टीन फोटो इलेक्ट्रिक इफेक्ट कहते हैं। इसे आप सभी नोट कर लो। उन्नीस 1905 में इन दोनों ऑब्जर्वेशंस के आधार पर आइंस्टीन ने एक फॉर्मूला दिया जिसे आइंस्टीन्स फोटो इलेक्ट्रिक इक्वेशन कहते हैं। इन 1905 फोटो इलेक्ट्रिक इफेक्ट was given by Einstein. This is based on Planck's quantum theory. According to Planck's quantum theory, light travels in the form of a small bundle of energy, a small pocket of energy. Energy of each bundle, each pocket is known as a photon, and energy of photon is h nu. H is Planck's constant, nu is the frequency of that light. H is Planck's constant, and nu is the frequency of light. According to Einstein, when light falls on the metal plate, light falls on the metal plate means photons fall on the metal plate. Light falls on the metal plate, then they lose their existence. उनका अस्तित्व समाप्त हो जाता है। लेकिन आप जानते हो कि एनर्जी neither be created nor be destroyed but transformed from one form to another. यह एनर्जी जो है वह समाप्त नहीं होती है, यह एनर्जी एक से दूसरे रूप में कन्वर्ट हो जाती है। अर्थात जो फोटन्स मेटल प्लेट पर पड़ते हैं उनकी एनर्जी अगर हमारे पास h न्यू है तो कहते हैं that energy is divided into two parts. First part is used to eject electrons from metal plate and second part is used to give kinetic energy to the ejected electrons. First part is used to eject electrons from metal plate, that is work function, and the second part is used to give kinetic energy to the ejected electrons, Ek. Means h nu is divided by two parts. First part is work function and second part is kinetic energy. W, that is the work function, and Ek, that is kinetic energy. Work function is also energy, that is h nu naught, and Ek kinetic energy is half mv square. H nu is equal to h nu naught plus half mv square. H Planck's constant, nu is the frequency of incident photons. H is the Planck's constant, nu naught is the energy and frequency of ejected electrons, and half mv square, m is the mass of ejected electrons and v is the velocity of ejected electrons. From this equation you write h nu minus h nu naught is equal to half mv square, means h nu minus nu naught is equal to half mv square, that is Einstein's photoelectric equation. Einstein's photoelectric equation. अब जानना है वर्क फंक्शन. वर्क फंक्शन मीन्स W is equal to h nu naught. Work function is the minimum energy below which no electrons are ejected. एक मिनिमम फ्रीक्वेंसी एनर्जी होगी जिससे नीचे की एनर्जी की कितने भी फोटॉन्स गिरते रहे इलेक्ट्रॉन्स इजेक्ट नहीं होगा, इसलिए इसको कहते हैं मिनिमम एनर्जी बिलो विच नो इलेक्ट्रॉन्स are ejected. Here mu naught is the frequency, that is minimum frequency below which no electrons are ejected, and that is threshold frequency. Threshold frequency. Here W, that is minimum energy below which no electrons are ejected. Now next is nu naught, that is the minimum frequency below which no electrons are ejected, and that is the threshold frequency. The conclusion is that the electrons The conclusion is that first conclusion is the rate of emission of photoelectrons varies directly as the intensity of light. The rate of emission of electrons varies directly as the intensity of electrons. The second is the kinetic energy does not depend on the intensity of electrons, but kinetic energy depends upon the frequency of photoelectrons. The threshold frequency of different metals are different. The 5 is if the electrons, photoelectrons or photons is if the frequency of photoelectrons or photons is less than the threshold frequency the electrons do not eject. The next is when light, as soon as light incident on the metal plate, electrons are ejected instantaneously if the frequency is greater than threshold frequency. There is no time lag between incident photon and ejected electrons. There are 6 conclusions. The first conclusion is a rate of emission of electrons varies directly as the intensity of electrons. The next is the kinetic energy does not depend on the intensity of electrons, but kinetic energy depends upon the frequency of photons, photoelectrons. The threshold frequency of different metals are different. If the photons having frequency less than threshold frequency, no electrons are ejected. If as soon as light is incident on the metal plate, electrons are ejected instantaneously. There is no time lag between incident photon and ejected electrons if the frequency is greater than threshold frequency. That effect is known as photoelectric effect, and given by Einstein, that is known as Einstein's photoelectric effect. That equation is Einstein's photoelectric equation. आप इसे नोट कर लीजिए 5-6 पॉइंट्स. मेडिकल इंजीनियरिंग में इससे कई क्वेश्चंस पूछे जाते हैं और आईएससी +2 सीबीएसई में फुल क्वेश्चन पूछता है, 5 मार्क्स का क्वेश्चन पूछता है. एक्सप्लेन आइंस्टाइन्स फोटोइलेक्ट्रिक इफेक्ट एंड गिव द इक्वेशन ऑफ आइंस्टाइन्स फोटोइलेक्ट्रिक.
¿Cómo se llama?